Hello, welcome to this lesson where our intention is to perform geometric rotations. We're going to limit our rotations about the origin. This is the origin of the coordinate plane, where the y-axis and the x-axis intersect is the origin. So our rotations are going to be about the origin, and we will only perform 90 degrees rotations, 180 degrees rotations, 270 degrees rotations, and if we do a complete rotation, then we do 360 degrees, which brings the object back to its original position. So a few things to note with rotations is that every point that is always the same distance from the center of rotation. So remember, the origin is going to be our center of rotation. So we're going to call this origin here the center. So every rotation will be about the origin. Now we will consider the coordinates of a point here. We are going to take this point that has x coordinate 4 and y coordinate 5 and call it A. So A has an x coordinate of 4 and y coordinate of 5. Okay, so remember how to read coordinates. You go straight down to the x-axis. The x-axis is, when we are doing rotations, the x-axis is always going to be considered as this horizontal line that has a right side and a left side of 0. On the right side of 0, we always have positive numbers, and on the left side of 0, we have negative numbers. Above 0, we have positive numbers, and below 0, we have negative numbers. Okay, so that may be a lot, but we are going to limit our rotations to, like I said, 90 degrees, 180 degrees, and 270 degrees. Our rotations will be done either clockwise. Okay, so this is the direction of clockwise. Following your right hand, this will be a clockwise rotation. And if you are rotating towards the left, then it is a counterclockwise rotation. A rotation is simply a turning effect about a center of rotation. Okay, and we measure a rotation in degrees. Okay, a rotation produces an angle that is measured in degrees. For example, this pen right now has a center. I've put the tip of this pen at the center of rotation, and the pen lies on the y-axis. So a rotation simply means I hold it down at this center, and then I turn the pen. If I turn it all the way so that it is now sitting on the x-axis, then I have done a 90 degrees rotation from here all the way to here. How do I know that rotation is 90 degrees? This is a protractor. This is an instrument that is used to measure angles of rotation. To measure an angle of rotation, first you want to fix your protractor, the center of your protractor at the center of rotation. So I fix that at 0, where is the center of rotation. Then you can see 0 right here. This is the start of the rotation at this 0 right here. If I rotate all the way, you see the x-axis line right here. This is 90 degrees. That is how I know that I have rotated from here to here is 90 degrees rotation. So this instrument is used to measure the angle of rotation. Okay, but however, we can do rotations without using this instrument to determine the angle. We can do a 90 degrees rotation without this instrument, and I will show you how. So first, let's get a straight line from this point A to the center of rotation so we can see how this line is going to rotate 90 degrees when we perform a rotation. So one way of doing the rotation is to use your coordinate grid as a tool. Okay, use your coordinate grid as a tool. you see 90 degrees rotation here. So let us perform the following rotations. Let's perform a 90 degrees clockwise. You see this arrow here means 90 degrees clockwise rotation on A, okay, and see what the coordinates A prime, the image. We want to see what the image will be after we perform that rotation. Okay, so this will be the X and the Y coordinates. Okay, we will also perform a 180 degrees clockwise rotation. And for 180 degrees, whether you do the rotation clockwise or counterclockwise, you end up with the same coordinates. So we want to do that on A as well, and we will call our coordinates A prime. Okay, so let me put this over here. We're going to call that A double prime, okay, so that it's different from the first one we did. A double prime, we want to get the coordinates here, and then also we want to do 270 degrees clockwise rotation on A, and our coordinates will be A triple prime, 1, 2, 3. Okay, so those primes are just ways of showing you that this point is different from the original point. Okay, so we will have a certain X coordinate here and a certain Y coordinate here when we're done with the rotation. So let's get started. The 90 degrees clockwise rotation. I will turn my paper. I'll use my paper as a tool. Okay, turn that coordinate grid so that this axis that is pointing away from me is considered as the 0 point, the starting point. So I will turn it so that this 0 gets to this 90 degree position right here. When it gets to this 90 degree position, then I imagine that this has moved to here. Okay, so when it is moving, everything else will be moving as well. So you want to pay attention. 90 degrees clockwise rotation, and then boom. Okay, and plot the point 5, -4. Okay, so 5, -4 is right here. So this is where A prime will be, where A prime represents a rotation of 90 degrees clockwise. So our A prime coordinates right here. Okay, our A prime coordinates right here are 5, -4. So if we plot 5, -4 there and use another color to show the new line from the origin, from the center of rotation to that new point, the line will look like this. There. Okay, so this line, we have rotated this line from here to this red line. So this is the angle of rotation right here. Okay, I did not use a protractor to measure this angle, but I can tell you with certainty that this angle is 90 degrees. Now let's use a protractor to measure that angle and confirm if it is 90 degrees. If it is 90 degrees, then we will also measure the length of this line to make sure that the length of the line is staying the same. If the length of the line two are the same, then we have successfully done a rotation of 90 degrees. So let's start with the angle. Okay, so remember to measure the angle, you put the center of the protractor at the center of rotation. You adjust the protractor so that the 0 line is on A. Okay, so center, and then okay, let's make an extension of this line of A so that we can see how it touches the protractor. We go ahead to place this center of the protractor at the center of rotation, and then now this is why we dotted this line out, so we can see that this 0 right here, we can see that this 0 right here aligns with the line as well. Okay, now that we align that, we read the angle 10 degrees, 20 degrees, we go all the way. Okay, we go all the way. We need to adjust so that that is aligned. We go all the way, and make sure this is adjusted to the origin, the center, and then okay, and then we go all the way. Now we see that this red line is reading 90 degrees right here. So we have rotated 90 degrees, okay? We have rotated 90 degrees. Now, the property of rotation says that the length of the line should stay the same. So let's go ahead and take a measurement from the origin to A in centimeters. What is the length of this line that goes from the center to A? Okay, 6 centimeters. All right, let's measure this other line here that goes from the origin to A prime, 6 centimeters. Okay, so we have respected the two properties of rotation. The length of the line has stayed the same after the rotation, and the angle of rotation has been measured to be 90 degrees. So this strategy works for doing a rotation about the origin. Now that we know that the strategy works, let us go ahead and quickly do a 180 degrees rotation and get coordinates of A prime. So this is our original A. Rotating 180 degrees, you could do counterclockwise or clockwise, it will end up with the same thing. So you want to go 90 degrees 2 times will be 180. So I do 90 degrees and then I do another 90 degrees. Okay, so my A is over here. My A is over here. Okay, I read the x coordinate of my A. It says 4 right here, but I know this 4 is not positive because this is the left side of 0. So it will be -4 for x, and my y will be, my y says 5 here. It is not 5. This vertical line below 0 is always negative, so it will be -4, -5. Okay, so after 180 degrees rotation, I get coordinates -4, -5. So I can turn my coordinate grid back to the original position, and then I plot -4, -5 right here. This is where A double prime will be. And that makes sense because 180 degrees angle is also called a straight angle for a reason. Okay, so if I rotate this line around 180 degrees, then this is where it will be. So that means if I start from here and then I go on that straight line and I get here, then I have done 180 degrees rotation. Okay, the last one is 270 degrees. That means we're going to do 90 degrees 3 times. Okay, so this is a paper in the original position. We go 90, but hold on, yes, at 270 degrees is clockwise, so we go 90, second 90, third 90. Okay, we go to our original A point. This is it right here. Okay, it is over here. I am reading the x coordinate on the horizontal line. It says 5, but this 5 is not positive. This is the left side of 0. This is 0 here. This is the left side of 0, so this 5 should be negative. Okay, then up here it goes up, and then it says 4. Yeah, I'm above 0 here, so this 4 here is positive. Okay, for the y. So the coordinates will be -5, +4. Okay, so after 270 degree rotation, I will get -5, +4. So if I plot the point -5, +4, that is right here. So this is where A triple prime will be. So if I were to turn this line, that original line, all the way 90 degrees, 180 degrees, and then 270 degrees, the new line will be over here. The new line will be over here. Boom. Okay, so if I started here and I do that whole turn all the way to this line, then I have done 270 degrees rotation clockwise. And that is how we perform geometric rotations.